In this section, we're talking about continuity. Sorry, got a little twisted there. A continuous function has no holes, breaks, or jumps. That means it's continuous. It's a smooth curve. But if we do have a hole, a break, a jump, an asymptote, that means that we're discontinuous at that point. And there's three conditions that talk about continuity. First of all, f of c is defined. In order to be continuous, you have to have a point there. That means it has to be a closed circle at that point. Secondly, the limit must exist. Okay? So that's important. The limit must exist. And lastly, the limit must equal the function value. If any of those conditions fail, it is not continuous. So at this particular problem, I have a graph here. I notice carrying on my graph that there's an open circle at 1. That means it's discontinuous at 1. There's also an open circle at 2. That means it's discontinuous at 2. There's also a break in the graph at 3, so that means it's discontinuous at 3 as well. Now let's talk about why it's discontinuous at these values. Here is when x is 1, right here. What I notice about that one is it's an open circle. There is no closed point when x equals 1. So the reason that it is not continuous at 1 is that f of 1 is not defined. F of 1 is not defined. So that means it violates condition number 1. F of 1 is not defined. Okay, so let's move on along to 2. At f of 2, I see that I have a limit, because if I follow along the graph, as I approach 2 from this way, the limit goes to 3. And as I approach 2 from this way, the limit goes to 3. So there is a limit there, and that limit is when y is 3. There's also a function value there. There's a point right here. That's when f of 2 exists. F of 2 is 5. But what I notice about those two locations is the two do not meet up. So we are discontinuous here because it violates condition number 3. And the reason for that is the limit value does not equal the function value. And so that's what's wrong with that one. So then we come across to x equals 3. And that also has a hole in the graph. But what I notice about x equals 3 is that if I approach 3 from the left, y goes to 0. And if I approach 3 from the right, y goes to 1. So what I know about that one is that the limit does not exist. So it fails condition number 2. The limit does not exist. Now, since the limit doesn't exist, that also means the limit doesn't equal the function value, but all it takes is one failed attempt, and that lets you know it's discontinuous at that point. Now the main way we're going to find these is with functions. So you have some theorems on your note sheet. It says a polynomial function is continuous everywhere. In other words, we're looking for the domain. So if I said, where is this function continuous, x squared minus 4, it would be continuous everywhere from negative infinity to infinity. So what you're looking for is there's no way to get 0 in the bottom, there's no way to get an imaginary number I, there's no way to get an asymptote, so any number you plug in would give you a number back, so that would be a good smooth curve. If you have a polynomial, it is continuous everywhere, and we write that as negative infinity to infinity. Okay, a rational function is a fraction, and a rational function is continuous wherever it's defined. It's discontinuous where the denominator equals 0. So I ask you, where is this function continuous? So you're going to set your denominator equal to 0 and solve that out. Okay, so when I get that, 2 makes the denominator equal 0. So that means 2 is bad. Okay? Every number in the world would work except for 2. So the way that we write that is we write it in interval notation. Here is the number 2. Okay? That means that all of these numbers over here work, and they would give you a good value. All of these numbers over here work. You just have an asymptote at 2. So the way that you write your continuity, it would be all of the numbers up to 2, not including 2, and all the numbers on this side of 2 to infinity. You'll say, but you're excluding 2. Why do you put it in there? Well, the reason that you put it in there is the definition of parentheses and brackets in interval notation. So what a parenthesis means is I get as close as I can to 2 without including. So I would go up to like 1.999999999, and parentheses means you get that close but you don't include it. So what a bracket means is that I would approach 2 and get all of the numbers up to 2 and include 2. So that's the difference between the two symbols there. But again, for our purposes, if we have anything from the denominator, we will always use parentheses around it. Okay, the next thing we have is radicals. It says if the index is odd. Okay, so what I'm referring to as the index is this little 3 right here. 3 is an odd number. If the index is odd, the function is continuous everywhere. So I ask you, where is this cubic function continuous? It would be continuous everywhere. The reason for that is that you have imaginary numbers on square roots. You don't have imaginary numbers on cubed roots. And so that's why that one would be all numbers. All numbers would work. If the index is even, what you have to do is set the radicand greater than or equal to 0. So in other words, if you're writing down some notes, you would take your radicand and set it greater than or equal to 0. This is a square root, so the index is understood to be even, so I would take x minus 7 and set it to greater than or equal to 0. I'd add 7 to both sides, and x is greater than or equal to 7. Now in an online course, multiple choice is the way that you work it, and so in a multiple choice setting, make sure you pick the one with the bracket. Parenthesis would not be the correct answer for this one. So that's how that one would look. So I give you some hints, and it says for a polynomial, a trigonometric, a root, or a rational function, you find the domain to find continuity. Okay? If you have a split function or a piecewise function, you have to determine, does the limit exist at that point?